In this chapter, we are diving into a topic at the intersection of AI and medicine: edge versus cloud AI in biomedical systems. By the end of this lecture, you should be able to understand the core differences between edge AI and cloud AI, explore how both are applied in biomedical technologies, learn from the real-world case studies, and identify some emerging trends shaping the future of AI in healthcare. Let's start with cloud AI. Here's how it typically works. Data from a device is transmitted via the internet to remote cloud servers. There it is processed using powerful GPUs or TPUs. Then the results are sent back to the user. This model is great for handling large-scale data and running complex algorithms. Few advantages of cloud AI are scalability for millions of users, easy and centralized updates to AI models, and access to vast datasets for training and fine-tuning. Along the benefits, there are also few downsides of cloud AI. It requires an internet connection. There is latency which can delay critical feedback. And of course, data privacy concerns, especially with sensitive health data. Now let's look at the opposite approach, HAI. In this setup, the AI algorithms runs locally on the device itself. This could be a smartphone, wearable, or even a tiny embedded chip, and it includes real-time processing. Edge AI comes with its own benefits. Because the data does not need to travel to the cloud, Edge AI allows real-time processing, offline functionality, and greater control over privacy. However, it is not without limitations. Edge devices have limited computing power and memory. You often need to compress or simplify models to make them run effectively, and updating models across many devices can be complex. Let's explore this with a real-world use case: wearable health monitors like the Apple Watch or BioPatch. In a cloud AI setup, data is continuously uploaded for long-term analysis. This helps detect patterns or anomalies over time, like irregular heartbeats. On the other hand, with Edge AI, the wearable itself can detect and alert the user to an arrhythmia or like atrial fibrillation in real time without needing the internet. Another powerful example is smart imaging in hospitals. With cloud AI, hospitals can use platforms that process radiology scans, CT, MRI, PET in the cloud. This supports multimodality analysis and central data management. In contrast, Edge AI can be embedded directly onto the imaging machines. For example, GE AX uses AI on online device to optimize MRI scan planning, improving speed and accuracy. Of course, these technologies come with challenges. On the edge, we must compress models through techniques like quantization or pruning to fit into limited hardware. Security becomes an issue, especially if the device is lost or hacked. On the cloud side, there is dependency on the internet uptime. If connectivity is lost, functionality may stop. And then there is bias. Cloud models are trained on centralized data may not reflect individual variability. Edge AI would help by personalizing locally. What's next? Here are a few exciting trends. Federated learning. Training AI across many edge devices without centralizing data, preserving privacy. Second is tiny machine learning. Bringing machine learning to tiny ultra low power devices like microcontrollers. Then 5G networks, enabling faster hybrid AI systems that combine cloud power with edge responsiveness. And new AI accelerators like NVIDIA Jetson and Edge TPU are pushing the boundaries of what's possible in real-time on-device healthcare AI.